Good morning, students. This is Rahul sir, and you are most welcome in Mindwork classes. In previous classes, we studied about sets. Now, from today onwards, we are going to study about the next chapter, that is second chapter, that is relation and function. Okay. So, in this chapter, the first topic is Cartesian products of sets. Let's understand what is Cartesian product of. Okay, so what do we understand by Cartesian product of two sets? So let us we have a set A, that is, in this set A we are having some elements like A, B, C, D and E. Now another set we are having, let us say, that is B. Okay, and in this one we have elements 1, 2, 3, 4, 5. Okay, here we are having two different sets A and B, in which these are the given elements. Okay, now if we have such type of sets and we want to find out the Cartesian product of two sets, that means A into B. Okay, now what does A into B means? This means this will give you few elements like this. Take one element from this one and one element from this one. A comma 1. Again same, A comma 2, A comma 3, A comma 4, A comma 5. Next, B comma 1, B comma 2 dot dot dot, B comma 5, comma C comma 1, C comma 2 dot dot dot. Likewise, we will have E comma 5 at the end. So the sets of all these elements is known as the Cartesian product of set A and B. Okay, so this is called Cartesian product. So please understand here, in general life, let's talk about take an example like the number plate of any bike or any car. In that we have, for UP it is UP, for MP DL for Delhi. Okay, so let us have some set A, that is, in which the name of any state is given UP, MP, DL Delhi, and set B, let us take the district number, that is 71, 78, 73, etc. Maybe any other numbers. Okay, so the Cartesian product here, Cartesian product of A and B, we get A cross B, that is UP 71. This is for Fatehpur. Okay, comma UP 78. Okay, like this. All the elements, if we make like this is called Cartesian product. And in this case, please understand here, in this case, UP is first element and 71 is second element. So in this case, this order is important. In this case, this order is important. You must take this, consider this, that this order is important, that UP must be written first, 71 should be written later on. UP first, 78 later on, because This is Cartesian product of A into B. If the Cartesian product is A into B, that means the first element of this should be from A, the set A. This is UP, MP, DL. It can be from this set. So the second element should be from B. Here we have 71, 78, 73. So second element must be from B. Okay. Now if we multiply, please consider this, B into A. So what will happen if we do B into A? What we will get? 71 comma UP, 78 comma UP, like this. Okay, are we getting this? That means the number which is written here first is from the first set which is written here, that is 71. So 71 belongs to set B. So here, and B is written here first, later on it is A. So B into A should be written equal to 71 comma UP, 78 comma UP, like this. Okay. So this Cartesian, this is known as Cartesian product. If you put elements in the respective order in the given, for the given sets. Okay. Now if you write this in the set builder form, A cross B is equal to A comma B, such that A belongs to A comma B belongs to B. Okay. That means, what does it mean? It means first element must belong to A, and the second element should belong B, the second set. Okay. So this is called the Cartesian product of any two sets. Okay. Now there are few properties regarding this Cartesian product of set. Let us understand here. Let us say a set A has 7 elements. Number of elements 7. Okay. NA is 7 and NB is given 5. Okay. That means number of elements in A is 7 and number of elements in set B is 5. Then the total number of elements in the Cartesian product of A and B, that means NA cross B, will be equal to 7 into 5, that is 35, which represent NA into NB. Okay. So NA into B is equal to 7 into 5, that is NA into NB. So this is called the number of elements in the Cartesian product. Okay. So number of elements present in a Cartesian product. So here you can write like this. Okay. If, and please understand here, for multiplying, that means for finding out the Cartesian product of any two sets, for finding out the Cartesian product of any two sets, the first thing is that the set must be a non-empty set. That means set A should not be equal to 5 and set B should also not be equal to 5. That means there must be at least one element in both the sets. Okay. And there should be at least one element in both the sets. Okay. The number can increase infinitely, no problem. Okay. But at least it should have at least one element. Now, if any set, either of these two, any of these two have infinite number of sets. If any of these two has infinite number of sets, that means NA is equal to infinity. Number of elements in A is equal to infinity. If this is the case, then the product of NAB, any number n, okay, So n a into b is equal to infinity. Okay, so the Cartesian product of a and b in this case will be infinity. Infinite number of elements will be there. Okay, so this is known as the Cartesian product of two sets. Now let us understand about the Cartesian product of three sets. This is the similar case as the previous one. If you multiply three different sets and find the Cartesian product of that, so the same concept will be applied in this case also. There is nothing difference in this case. Like set A has 1, 2, 3, 4. Set B has A, B, C. Set C has alpha, beta, gamma. Okay, let A, B and C, A1 to 3, alpha, beta, A, B, C and alpha, beta, gamma. So if you find the Cartesian product of A, B and C, that means A into B into C. So what will happen here? The first element will be 1, 2, 1, A, alpha. Again 1, A, beta. 1, A, gamma. Again 1, B, alpha. Like this. So by this way you can find out the Cartesian product of three different sets. Okay, similarly you can also find the Cartesian product of same sets. Either there are three sets, either it can be also have two sets only. Cartesian product of one set and three sets also. Okay, so this like, so this is the case. Okay, now let's come to the exercise and try to solve few questions. Here, if x upon 3, first question let's take a look. If x upon 3 plus 1, y minus 2 upon 3 is equal to 5 upon 3 comma 1 upon 3, find the value of x and y. What do we do here? Directly in previous classes, in previous chapter we also studied about the equality of sets. If the sets are equal, that means the respective elements must be equal. Okay, here, so x upon 3 plus 1 is equal to 5 upon 3. Okay, so from here you can find out the value of x. Okay, similarly y minus 2 upon 3 will be equal to 1 upon 3 and you can find out the value of y. Okay, so solve few questions, and if you find any problem please ask me. Thank you.